Good morning, students. It is chapter number 3, lecture number 4 for 12th physics students. Today's topic is meter bridge and potentiometer. First, we will discuss meter bridge. This is meter bridge. In this meter bridge, PQ is a 1 meter long resistance wire. It is connected with thick metal strips. And there are two gaps, 1, 2. Across one gap, generally known resistance is connected. Resistance box R is the known resistance. S is unknown resistance. At point C, galvanometer is connected and second end of the galvanometer is connected to jockey. And jockey's end is sharp and point PQ, across point PQ, a supply is connected with the help of key. Galvanometer. Now galvanometer is a highly sensitive device. It is very, very sensitive for the current. If there will be any small amount of current in the circuit, then this galvanometer will show deflection. So if there will be no current, then there will be no deflection. And the galvanometer 0 is at center. We have seen in case of voltmeter or ammeter, 0 is on extreme end. But in the galvanometer, it will be at the center. And on both sides, there will be divisions 0, generally 0 to 30. Reason is we do not know in which direction current is flowing. So 0 will be at the center. So we do not know which terminal will be positive, which one will be negative. So due to that reason, 0 is kept at the center. Now, before that, what is the principle? It is based on the principle of balanced Wheatstone bridge circuit. In the previous topic, we have studied about the balanced Wheatstone bridge circuit. If there are 4 resistances connected across 4 sides of a rectangle, supply is connected across one diagonal and across second diagonal, galvanometer is connected. If no current flow through the galvanometer, then that will be balanced Wheatstone bridge circuit. Now coming to this problem. R, known resistance, which was in gap between A and B. S, unknown resistance. Null point was at E, that is no current was flowing through this galvanometer at point E. So PE, this length, which is equal to L. So remaining length will be 100 minus L because total length of this wire is 100 centimeters. So R and S, these are two resistances. One is known, second is unknown. Point C was connected with galvanometer. Suppose X is the resistance per unit length, so Lx will be the resistance in one side and 100 minus L into X will be the resistance of the other side. Across one diagonal, supply is connected. Across second diagonal, galvanometer is connected. And as no current is flowing through the galvanometer, it means it is a balanced Wheatstone bridge circuit. So if it is balanced Wheatstone bridge circuit, then according to rule, balanced Wheatstone bridge circuit rule, R by S will be equal to Lx upon 100 minus Lx. X will be cancelled and we can simplify it for S. S will be R into 100 minus L divided by L. So that will be resistance which was unknown. So you can say it is unknown resistance. For the null point, this null point should be between 30 and 70. If it will be less than 30 or more than 70, then percentage error will be more. And we can adjust this null point by changing the value of the R. If ratio of R and S will be very high, in that case null point will be less than 30 or more than 70. So we will have to adjust the value of R so that percentage error, or you can say error, remains minimum. You will get best result if null point is around about 50 centimeter mark. So using meter bridge, we can calculate unknown resistance, we can compare two resistances, we can calculate a specific resistance. how to calculate specific resistance. We know the resistance of that wire S. After that we will cut the wire from both the terminals, measure the length of the wire, and then find out what is its area of cross section. So it means we know the L, we know area of cross section A. So we can find out what will be specific resistance. For calculating the area of cross section, we will measure the diameter of this wire using a screw gauge. It means we know the diameter, so we can calculate area of cross section. Our next topic is potentiometer. In potentiometer, there are multiple wires, 100 centimeter, then thick metal strip, again 100, thick metal strip, 100 centimeter, thick metal strip, again 100 centimeter. In this diagram, there are 4 wires, but there are 4 to 10 wires. Generally, a 10 wire potentiometer is used. More will be the length of the potentiometer wire, more will be the accuracy. Why? I will discuss that later. So it is a potentiometer. In this case as well, 1 meter scale is provided. This is the scale. Principle of potentiometer is, if a steady current flows through the wire having uniform area of cross section, then potential drop is directly proportional to length of the wire. I repeat, if a steady current passes through a wire having uniform area of cross section, then potential drop is directly proportional to length of the wire. Now how to connect and what is its purpose, or you can say where it can be used. We can compare EMF of 2 cells using potentiometer. We can find the EMF of a cell, and we can find the internal resistance of a cell using potentiometer. Now for circuit, point A is connected to supply E, battery E. Point A, it is connected to E, positive terminal is connected. After that, milliampere meter, then rheostat, variable resistor. After that, K1 key, and it is connected to second end of the potentiometer B. This circuit diagram will remain same in each case. This cell provides potential difference between point A and B, and this cell is called driver cell. It provides the potential difference. And what will be the potential difference between point A and B? This cell is providing some potential, that is, it has some EMF, and there will be some drop across this region. So net voltage provided will be applied voltage minus drop. So that is V. V is the net voltage across this. So V will be the net voltage across terminal A and B, or you can say across wire AB. Now we want to compare the EMF of 2 cells. Before that, V was the applied voltage, so V will be equal to ILX. I, the current flowing through this circuit. L is the total length of this wire, total length, that is from A to B. So in this case it will be 400 centimeters. And X is the resistance per unit length. So V by L will be equal to IX, which is also equal to K. I is constant because current is constant, so I is constant. X is resistance per unit length, that will also be constant. So V by L, it is called potential gradient. If value of potential gradient will be less, that is, if drop per unit length will be less, then potentiometer will be more sensitive, or you can say more accurate. Because for small variation in the voltage, there will be large length. So chance of error, or you can say percentage error, will be less. So potentiometer will be more accurate. And in the beginning I told you generally we used a potentiometer having 10 wires. So 10 wires means more length. So more length, it means it will be more accurate. So generally we use potentiometer having more length. Now we want to compare the EMF of 2 cells using this potentiometer. Now in this region, at point A, two cells E1 and E2 are connected positive terminals. For that driver cell, positive terminal was connected at A. For E1 and E2 as well, positive terminal is connected. Now remaining two terminals, or you can say two ends, will be connected to a three-way key. I have shown these as K2 and K3. Then high resistance box 0 to 10,000, then galvanometer, and from galvanometer to jockey. Now procedure. Procedure will be, first of all, we will insert K1 key. So there will be some deflection in the milliampere meter. So some current will flow through this. After that, we will insert K2 and we will remove 5000 ohm resistance from this high resistance box. Its range is 0 to 10,000. So we will remove 5000 ohm resistance. Then we will put this jockey on first wire, then on last wire. If deflection in this galvanometer are in opposite directions, it means this circuit diagram is correct. So null point will be somewhere in between. Then we will find out where is the null point. When there is no deflection in the galvanometer, then we will insert that 5000 ohm resistance as well, and we will make the fine adjustment. 5000 ohm resistance, it is a very high resistance. So if negligible current will flow, this galvanometer will show zero deflection, we will insert the resistance. So if there will be small amount of current at that point, then it can show some deflection. Then we will adjust this jockey and we will find out where the exact null point. Suppose this null point is here. Then how to measure this length? 100, 200, 200 plus this remaining length. That will be length. Suppose that null point is here. In that case 100, 200, 300 and 300 plus this remaining length, this length. So that will be our length, or you can say at point is Z. At this point no current is flowing, it means it is a null point, no current is flowing, it means this potential or EMF of this cell is equal to drop across this wire. Suppose this length is L1. So E1 will be equal to IL1X, where X is the resistance per unit length. We know E is equal to IR. L1X, L1 is the length, X is the resistance per unit length, so L1X will be the resistance. So E1 is equal to IL1X. Similarly, we will repeat it for E2. For E2, we will insert K3 key. We will insert this key. We will repeat same procedure. Then we will find out where is L2. So E2 will be equal to IL2X. Then we will divide E1 to E2. So E1 by E2 will be equal to L1 by L2. So we can compare the EMF of two cells, and out of these two cells, if you know the EMF of one cell, then we can calculate the EMF of two cells. Now in this circuit diagram, it is possible that deflection may be in same side. That is, we cannot get, it is possible that we will not get any null point from point A to B. If we are not getting null point, then what are the possibilities or what are the possible errors? First thing, we are providing V voltage, that is E EMF of the driver cell minus some drop across this R prime resistor. If this value of V will be less than the EMF of the battery, E or E1 or E2 in this case, then we will not get null point. Reason is, suppose for example, suppose I say this effective voltage is 1.5 volt and EMF E1 is 2 volts. So from A to B, total drop will be 1.5 volt, but for null point, 2 volt drop is required, and maximum drop which we can get from A to B will be 1.5, so we will not get null point. So this is the first possibility. So in that case, increase the EMF of the driver cell or decrease the resistance R prime. Second possibility, second error, positive terminals should be connected to A. All positive terminals should be connected to A. If all positive terminals are not connected, in that case we will not get null point. Third possibility is there may be some loose connection. If there will be some loose connection, in that case as well, we will not get any null point. The effect of high resistance box are on null point. At a null point, no current flow through the circuit. Through this circuit, no current flows at a null point. So there will be no role of this resistance R on null point. That is, whether we increase or decrease this resistance, there will be no effect on the null point. It is only for the safety of this galvanometer, because I told you earlier as well, it is very sensitive device. So if there will be a small amount of current, then it will show large deflections. If current will be large, then it will be out of scale, deflection will be out of scale, and it will be damaged. So it is only for the safety of the galvanometer. It is not going to affect length of the null point. If we change R prime, suppose we increase this R prime. If we increase this R prime, then resistance in the circuit, that will increase. So what will happen? Current will decrease. And E is equal to ILX. So there will be decrease in the current I will decrease. So this length, null point length, that will increase. So if we increase the resistance R prime, then there will be decrease in the resistance, then there will be increase in the resistance, current will decrease, length of the null point will increase. Next is to find the internal resistance of a cell using potentiometer. In upper portion, circuit diagram will remain same. There is no change. In lower portion, we want to find the internal resistance of a cell whose EMF is E, which is connected here. Same high resistance box, galvanometer, jockey. Across this cell, resistance box S is connected with a key K3 and second end is connected here. First of all, we will insert K1 and K2. Then we will find out where is the null point as we did in previous case. So E will be equal to IL1X. IL1X. L1 is the balancing length, or you can say null point length. X is resistance per unit length. After that, we will remove some resistance S from this resistance box. Then insert K3. It is very, very important. Without removing any key from resistance box S, you cannot insert K3. If we insert K3 without removing S, then it will be short circuit. Positive and negative terminals. Positive and negative terminals will be directly connected. So it will be short circuit and it will catch fire. Because resistance will be zero. So high amount of current, large amount of current will follow this path, and I square R will be the heating effect. So it is a rule, first remove resistance S from this resistance box, then insert this key. Actually, what is advised when you make these connections, at that time remove some resistance, 10 ohm, 15 ohm or 20 ohms like this. After that we will insert K3. Resistance S was removed, K3 was inserted. Now current will flow through this. After that we will find out where the null point. At a null point no current will flow through this, but current will flow through this. It means current is drawn from the circuit at this null point. And potential difference across the two terminals of a cell when current is drawn from the cell is called potential difference, or you can say voltage. So that will be V. So V will be IL2X. And voltage is always less than the EMF, or you can say EMF is always greater. So L2 will always be less than L1. So if you are getting L2 more than L1, it means somewhere there was error. Either your second reading is incorrect or first one was incorrect. So we know E is equal to IL1X and V is equal to IL2X. We know internal resistance R is equal to E by V minus 1 into S, where S is the resistance removed from this resistance box. So we will substitute this value. R will be equal to IL1X upon IL2X minus 1 multiplied by S. This X will be cancelled. I will also be cancelled. So L1 by L2 minus 1 into S, that will be internal resistance. So we can find the internal resistance. Question number 3.12. 3.22, 3.23 and 3.24 of NCERT are based on this topic. So you can calculate these numericals, and if you have any problem, then you can contact me. All of my students know how to contact me. Okay, thank you.